Good afternoon, everyone. In the last class, we discussed about design concepts, right? How many design concepts we discussed? Anybody is there?
5, ma'am.
First, 5, abstraction, architecture, pattern, modularity, information hiding, we discussed. The remaining, functional independence, refinement, refactoring, design classes will be there. So I think if people remember this abstraction are 2 types, procedural and data abstraction. Procedural abstraction, we are hiding the procedure level details, and data abstraction, we hide the data level details, means like attributes of the data. And come to architecture, different architectural models we discussed. And patterns we are using for reusability, to increase the reusability of the project development. Reusable part are standalone units that we can use again and again. So patterns are a type of standalone units. There are some built-in functions that we can use in your projects. In your software development time, we can use the patterns that are reusable, standalone, inbuilt functions. Then design patterns types we discussed, architectural design idioms we discussed. Then we discussed about modularity. Modularity means module as a separate standalone unit that we can use. Module is also we are using for reusability purpose, and this based on mainly the software development is based on the divide and conquer rule principle. So divide and conquer rule means highly complex software. You can divide into different modules and we can work on each and every modules, and at last you can integrate into a system. So that we discussed, and different types of modularity, modular decomposability, modular composability, modular understandability, continuity and protection. This we discussed. Different terms which is related to modularity. Modularity was the software cost. Which one is good based on the number of modules? What is the cost and effort? Number of modules when at this is very important diagram. The number of modules when it is high, the number of modules when it is high, the cost per module is very less, because each and every module has very less complexity, or it is very simple. The development cost of each and every module is very less, but the number of modules are more. At the same time, cost to integrate means there are so many modules, because we divided into n number of modules. So to integrate these many modules takes a lot of cost. So cost to integrate is very high. Similarly, when the number of modules are less, you could see this integration cost is very less, because number of modules are less, but the complexity is more for each and every module. But what about the software cost, development cost? When development cost is very high. Why? Because this each and every module is very complex to develop, right? So total software cost is high. This dotted curve which represent the software cost, that is an ideal software cost. Here these two number of cost to integrate and cost to module, you have to plot for less number of modules and more number of modules, then it will intersect in a point. At a point, that point is, and from that point, that is a middle, considered as a middle point, and you can take a small area considered as central point, then you will get a region for minimum cost. Let's see, this is minimum cost. Here actually cost is high, either cost to integrate or cost to module will be high. So this is the lowest cost. We can why we plot this diagram. To our question is, okay, modularity is good, right? Because we are using divide and conquer rule. So if we divide into so many modules, then each and every module cost is less, but the integration cost is more. So which one is best, or how many modules are best? How many modules we can create from a software? That depends on the complexity, but we could finalize. We could conclude that the number of modules are, if it is more, if it is very high or very, very low, the cost to software creation is very high. So that both are not recommendable. In between, a medium means a moderate number of modules are good, irrespective of the project size or complexity. That is the conclusion of this diagram. Is it clear, the diagram? Modularity versus software cost. Is it clear? Is it clear or not? Next topic is information hiding. Information hiding means we are hiding unnecessary details. Why we are hiding unnecessary details? For example, when you create a module, the details like its algorithm, data structure, data content, which within that module, that you can hide, because no need to means hiding from other modules. Because all the when you write the class an object-oriented program, some variables we define as private or protected. That is also a kind of hiding. We are hiding those information from other modules. This is an example for information hiding. So, and other things are implementation details of data structure also. It's metadata. Those also we can hide from other, we can hide. One is to reduce the complexity, and other is all data are not relevant to other modules, right? So we will transfer some data from one module to another, but not all. So benefit when the modification occurred during testing and maintenance. Another thing is no need to include. For example, if some variables are accessible to other modules, if the module, for example, okay, when you are going for a testing and maintenance or modification timer, suppose if some variables are accessible from other module variables are accessible, it may create some problem. So we can use this information hiding techniques. And another thing is that suppose if there are any errors or bugs are there in one module, it may transfer from one module to another if it is a common variable. So you can avoid those things also, because error propagation that may happen. So that also we can reduce if you use the information hiding technique. So here you could see this is the there are multiple clients are there, multiple modules are there. Modules, actually one module is shared by multiple clients, but algorithm, data structure, and detail of external interface, resource of allocation policy of one particular module, that we can keep secret. That is called information hiding. some metadata and some algorithms and data structures, but some variables we can keep as private, or it's only accessible to the particular module, should not disclose to outside modules. That is called information hiding. Next is in functional independence. What is functional independence? Functional independence actually, every module is functionally independent. How can you create the functional independence? This by the cohesion and coupling. These two terminologies are very, very important, cohesions and coupling. These are two criteria to keep the functional independence. So functional independence we are achieving by single-minded functional law coupling. How is it possible? Each and every module should focus on a particular function. It contains multiple tasks, but all these tasks are integrating into one particular function. Then we can call it as that module is functionally independent to another module. So functional independence achieved by developing a module to perform given set of function without interacting with other part of the system. This is the definition for functional independence. So functional independence is achieved by developing a module to perform a given set of function. Every module has its own set of functions. These functions contain multiple tasks, means all these tasks are integrating to a particular function, but the interaction between the modules are less. Between module, every module is a standalone unit, but the interaction between the modules should be less. That is called coupling. Coupling means interdependency between modules. Those should be less, and intradependency means inside module, different tasks should integrate to a particular function. That should be high. So cohesion should be high and coupling should be less. Then we can call that module is functionally independent. So here in this diagram it represents different types of cohesions. This is coincidental coefficient. This among all this functional cohesion is the best one. It gives maximum cohesion. Functional cohesion, sequential, communicational, procedural, temporal, logical, and coincidental. This is the order. So the functional sequential cohesions are good cohesions. Then coincidental logical cohesions are weak cohesions, and the remaining, the middle, is moderate cohesions. So, but the best is always functional cohesion. Here you will see the low cohesion and the high cohesion. High cohesion is a good programming practice. Low cohesion is allowed, but it's a bad programming practice. What is it? You could see here class A, check result, send mail, send email, print letter, and print address. Different operations are there in a class A. So class A contain different functions. Here, class A, class B, class C, class D. All these functions which are different. Check result, send email, print letter, print address. There is no logical connection between these classes and these functions, and all these functions will be divided into different classes. Means cohesion is high, but here cohesion is less. Why? Cohesion means why this cohesion is high and low here? Here interdependency is more, right? Between all this different functions which does not have any logical connection, that we all comes under same class, means the interaction between these functions are very much more. So you can reduce that interdependency. Then we can say this. Then we can to reduce the interdependency between the modules, you can divide into different classes with different functions. So this is a good programming practice comparing to this. The same thing represented here in class multiply, and class display. These two functions does not have much mul function and print function does not have any common thing, but always we are multiplying, and after that we want to display the value, right? So the display also comes a part of multiply, but both we declare in same class. So the class display and class multiply. But these are not related functions. So it's better to separate module, not in single module. You can define in different modules, like here, class name, class age, class number, class display, everything is separate classes. So this is good programming practice comparing to the dependency between the modules. So here, this display, inside the display class, we call the multiply function, right? Multiply function we are calling here. So the dependency is more here. So when it comes to functional cohesion means functionally dependent, means logically dependent functions we can group together into a single module. For example, a student attendance. You wrote one module with student attendance. That is main function is student attendance. That function contains different sub-functions like present day, absent day function, present person. But all these functions work together and to generate the attendance report. So attendance report, generating that attendance report is the particular module function or particular module output. But to generate that output, we need another sub-functions. All these functions are logically connected, and we can group all these functions in a single module. That is called functional cohesion. That is a very good programming practice. So the best, strongest cohesion is we can functional cohesion, that is different tasks which support a main function that we can group together in a single module. It increases the cohesion. So that is called functional cohesion. When it comes to sequential cohesion, also one of the good cohesion, but in this, the sequence of one function means the output of one function depends on is passing to the next function. So there is a sequence of operation. The different functions are there in the module, but we have to follow a particular sequence. The output from one function is the input of another function. Okay, if you arrange in this way, you can call it a sequential cohesion. That also one of the best cohesion method. So strongest one is, which one is strongest one? Functional cohesion, and sequential cohesion also one of the best cohesion. Then communicational cohesion means if we in a module, there are multiple functions are there. All these functions are share same data structure. Means either we are taking input from the data structure or we are giving the output to the data structure. Then, or if all these functions are updating, then we can call it as same, means same data structure is shared by different functions. Then we can call it as communicational cohesion. And those all, suppose if same data structure different is sharing by different function, all those functions we group together into a module, we can call it as communicational cohesion. The next is procedural cohesion. Procedural cohesion means there are different functions. For example, you are downloading data. You want to write a module to download the data from the email. It contains different functions. The downloading data means first you have to not downloading that, downloading an email content. Okay, so then you have to first log in. Then you have to select the particular mail. That is another function. Again, you have to open that mail and you need to download the content, and again you have to log out. So these different operations are there, all different functions are there. All these functions are logically related. But they are doing different things, right? Different things, and different data is using as input. But there is a sequence. But all these are executed one after another. Because first the order is very important, right? There's a procedure is there. Means first you need to log in, then you need to select, then you have to need to open, then you can download. The order is very important. The procedure, all these functions are working towards all these functions. Actually, they are independently, they are working for different purpose, but they are operating. Excuse me. Okay. Okay. It contains different functions. Like all these are separate function. All these functions are working on different data, because login data is different. Your credentials are needed to log in. Then when it comes to mail, selecting mail means a mail list is your data input. Then that is the input for open mail also. But when you are downloading the content, the content is different, right? The download attached to mail content is the input. And when you log out data is different. It is either it needs username, password. We are working on that data, so we are log out from the particular username. So this is the different functions, and all these functions are independent of each other. At the same time, it's related with the order, but it works on different data. If this is the situation, means we can call it as procedural coefficient. It's based on the order of execution. There is a relation with order of execution. Okay, then it is called procedural cohesion. The module contain different functions. All these functions are executed one after another. But these functions are working in different purpose, in different data, not common data structure. Then we can call it as a procedural coefficient. That is one of the moderate coefficient type. Are you listening? How many of you are listening to class? Actually, I'm speaking. I'm taking class. I don't know. It's very important. That's why I'm asking. It's very important topic. Eight participants. It's really eight people are listening out of. How many are there? 46 out of 46. Okay. 16 students. The number is very less still, but A temporal cohesion. What is temporal cohesion? Temporal cohesion means it depends on the time span. Means it depends on the time. For example, when you switch on your computer, first operation is boot operation, right? So at the same time, what is booting? Booting means there is a bootstrap loader program which transfer operating system from the secondary memory to primary memory for execution, right? That is a bootstrap loader function. So at the same time, post test is there, power on self test is there. So multiple operations are doing parallelly or at the same time. So, but all these functions are related. So these type of functions are called temporal cohesion. If so, we can include all these functions in a single module. Then we can call there is a temporal cohesion in that module. A module contains different functions. They are related by facts and then the time of execution of the time span. Then we can call it as a this module functions possess temporal cohesion. Okay, so bootstrap loader loading operating system from the secondary memory to main memory or RAM. At the same time, it check the BIOS status and do the post test, power on self test. So all this are all these functions are related to each other on basis of time span. So this is the temporal cohesion. It's one of the weak cohesion actually. Then logical, from the name, I can identify elements in module perform similar task. Similar task means logically some similarity should be there. We can call it as logical cohesion, like data input, data output, error handling. These are logically cohesive in nature. For example, a scan function. Scan function means you can scan, it contains different modules. Scanning annual report, scanning performance report, we are storing in different data structure. But all this scanning, different types of reports, all are logically related because all are doing same function scan. But there is not much other than this logical connection. One is not depend on another thing. So there is dependency is not there. Functionally it's not related. Time is not related, not based on time, but it's based on the logic. Logically, all this comes under the same scanning. So these type of cohesions are called logical cohesion. So this is an example. Then coincidental cohesion, as the name itself, it's happening coincidentally. There is no particular reason. A module containing different set of tasks. All those tasks comes together in a module by coincidentally. It's very loosely coupled, means loosely arranged. So that's why we call it as coincidental cohesion. If a module performs certain set of tasks which relate to each other very loosely or doesn't relate to each other, there is no relation sometimes. All these functions comes in a particular module by coincidence. And this type of cohesion is called coincidental cohesion. It's the weakest of all. Sometimes there may be a relation, sometimes there may not be a relation. There is no guarantee in the relation between these functions. That type of functions come together by coincidentally, then we can call it as coincidental cohesion. Now, these all type of cohesions are important, and all this cohesions comes under functional independence. Cohesions and coupling. Coupling actually we will discuss in the next module in detail. I think it is there in the syllabus. Okay, is it clear? How many of you it's clear? No one will open mouth. Is it clear or not? Clear by one. I got one person respond.
Yes, ma'am.
Yes. So this cohesion means you should understand what do you mean by cohesion, and why some cohesions we consider as strongest and why some are weakest, one are moderate. Which one is best for your software? Always high cohesion is best, because then all functions which are related each other, there comes under in one module is best. Then some there are different types of functional dependencies are there. Some are based on the order, some are based on the time span, and some are based on the logical relations, some are based on the sequence of operation. Different types of relation between these functions are there, but best is all the tasks which are focusing on one particular function or comes under same module is the best. Okay, so that cohesion is called functional cohesion. So next topic is refinement. Refinement means it's complementary to abstraction. Refinement is different than complementary. Here actually we are abstraction means we are hiding some details, right? Refinements means we are showing some details. Means showing details, but still there is a level of abstraction is there. Means you are not disclosing all the details, internal details at a time. You are disclosing one by one. Like a DFD, DFD 0, DFD 1, DFD 2 are there. DFD 0 is an overview. DFD 1 give the internal details. When it comes to DFD 2, a particular more part of that functions details we are disclosing in or discussing in detail. So this is the it's a type of refinement. Like refinement is development of program is successively refining the level of procedure in detail. So we are elaborating that we start from higher level abstraction to lower. Higher level abstraction means we are not showing any internal details. Like one of the examples, use case diagram. Use case diagram, we are not showing any internal details. We simply show how it looks from outside and how all the modules are and component diagram. And this deployment diagrams is just an overview, not showing any details inside details. So that is higher level abstraction. When it comes to lower level means we are successive refinement. Successive refinement means we are showing the details at some point, but not in a single step. So we are suppressing some lower level details. So that is called refinement. So refining means you're showing more and more details, but in later stages. So you should remember the point. It is complementary to the abstraction. Abstraction and refinement are exactly complementary. Both are explaining complementary. The next point is refactoring. All this comes under design concepts. Refactor means suppose, simple way means without changing the functionality of a module. You're just modifying that function, modifying that module without changing the functionality or without changing the external behavior of the code. You're not you're not changing anything, any internal data structure, but you're improving it. Improving it means you optimize it. Sometimes, so for example, some redundancy is there. Some redundancy means suppose if some variable we repeatedly assign somewhere, it's unnecessary. We are not noticing it. That is an example of redundancy. When redundancies are there, obviously inconsistencies will be there. So you can remove the redundancy. There are multiple ways to remove it. It's not only in databases, even the programming also. There are multiple variable. For example, x equal to 1. You are giving that variable x equal to 1 without in between. There is no modification between these variable. Then repeatedly you are giving you are assigning variable. Then it's wastage. Let's not give an error. There is no error. You could not maybe identify any error in your program, but efficiency will be reduced, right? So you can avoid redundancy. And unused design elements. Sometimes some design elements are there, but not all of you are using that. So if some dead elements are there, you can remove it. And inefficient, unnecessary algorithms are there. You can change the algorithms. You can change the algorithm. You can replace with a more efficient algorithm. Or poorly constructed inappropriate data structures are there. You can modify that. And some design phase. Okay, these type of things you can do without modifying the functionality or external behavior of the system. That is called refactoring. Sometimes optimizations also comes under refactoring. Okay, refactor. I think this is very important thing. You should remember, refactoring means modifying your code without changing the functionality or just improve the internal data structure. That is called refactoring. Don't get confused with refinement and refinement is you are showing the details, means you are disclosing the details consecutively, means one after another. That is refinement from higher level to lower level. But refactoring means modifying without changing the functionality. Is it clear to everyone? Then coming to design classes, this is last point in the design concept. Design classes means refine the analysis class by providing design detail that enable the classes to be implemented. Create a new set of design class that implement the software infrastructure. Nothing is that in the previous classes I explained about how to find out the classes. How to find, what do you mean by class and how can you find out the class and object? There are some guidelines to find out the classes. So all this comes, classes are not needed for your designing. So, but we will list out all these classes and from that we will choose the potential classes. But when you select the potential classes, you can categorize the different types of design classes. Some classes which we can use for the interfaces. Interface means use human computer interaction, like the output classes, output input classes, both. That class is called interface classes. Then business domain classes are there. Business domain classes means suppose if there is a problem, okay, we are actually what we are doing, we are finding solution for a problem, right? So which part is actually specify that problem portion and of the problem domain, which part we are using, that part we can call it as a business domain class. So the classes which represent that part is called a business domain class that are used to implement specific portion of the problem domain. that is called a business class. Okay, that is very important part of the classes, important classes. Then process class means the classes which are directly related to some process. That is called the process classes. Persistent classes means, for example, data stores. Classes which related to the data store is called persistent classes. Then this is different. We are categorized into different classes. That's it. All the potential classes, we have to first we are finding out all the classes based on those guidelines which I discussed in the previous unit. In that way, we are finding out all the analysis classes. From the analysis classes, we are choosing the potential classes. So in the potential classes, we can categorize into different categories, like the classes which are related to the interface, classes which are related to the domain area, classes which are related to the process, classes which are related to database, classes which are related to system management. So different categories are there in design classes. First, analysis classes. Analysis classes, we are choosing some potential classes which is very much relevant for your development, software development. The remaining classes actually we are just randomly we are picking first, but after that we choose the appropriate classes for your software designing. So from that classes you can categorize into different based on the functions performed by the classes. That is called these categories. These many categories, just remember it. So these are the main design concepts, very important. Abstraction, architecture, pattern modularity, information hiding, functional independence. All the cohesions comes under functional independence. Coupling also comes under this category. Then refinement and refactoring, don't get confused, both the concepts and design classes. So these are the main design concepts you need to. This is a framework for the design class designing. So next class I will discuss the next topic, design model. So is it clear to everyone? Any doubts? Any doubts on design class concepts? Only Preeti is responding. What about other students? What they are doing? Are they there or no? Only Preeti is there. I ask you, I can either answer yes or no. Do you understand? Assignment, I did not add the questions. I don't. I will do it. Actually, I created the assignment for case study, but the case study which I created contained agile method, but that method is not actually that agile methods are not there in your syllabus. That's why I stopped it. I removed that assignment. Actually, extreme programming is not discussed, right? It's not there in your syllabus. That case study belongs to that part. So I will remove it. No need to answer. Actually, I think I did not add the question also. I simply created one quiz, did not add the question. Okay, is it showing in your site? Then I will remove. Is it clear? I got a response from roll number 24 and 49. Is there any doubt? You can ask me. Every day I'm repeating the same thing. Do you have any doubts? Ask me, ask me, ask me. Nobody's asking any doubts. Okay, then we'll see you in the next class. Thank you.